Hello, it's Duncan. This week we take a break from writing production code by writing production code. Specifically, we want to deploy our delete items feature. Before we do, we find a way to finesse the nested transaction issue we found with our database access, then address a couple of edge cases in our logic, before turning on the feature flag in our production environment, checking that all is fine there, and then finally removing the flag altogether. What seems like a long time ago now, we were working on deleting items, and we'd implemented this delete items with IDs function in our app. And you can see we had these print lengths here, and that was because we were trying to establish whether or not calling items in transaction twice resulted in a single transaction or a nested transaction. And the conclusion we came to was that it was a nested transaction. And that's at least theoretically a little bit awkward, because in our load and update stock list here, we call items in transaction, and that's inside this items in transaction here. Now that's not necessarily a problem unless we have lots of simultaneous database operations happening, and we're pretty sure that we don't. But if the fix is cheap enough, maybe we should do it. Before we do though, we've evidently got some work in progress here, so let's find out which commit that was. That's all my fault apparently. Let's have a look at that commit. And this is instrumenting Duke transaction propagation, and that changed our delete items tests to include a transaction listener. So I think we could just revert that commit to tidy up. It turns out we've edited app since then, so let's see what it would take to merge. And it looks like we stand a chance with the magic wand. Let's commit that and see if it runs the tests. Well, we seem to be back on firm ground. Looking at delete items test, this is still using the database. I think maybe we could get away with just using in-memory items in here now. And that would mean that JUnit could run this in parallel with other things. So we could take that out, and we wouldn't need to clear the database before each test. Oh, well, we have a failing test. Just goes to show you can't assume anything. Let's have a look, see what the issue is. Well, it seems that we unexpectedly have no items. So we either deleted them all or never had any in the first place. The first seems more likely. In these situations, I like to just revert and check that it certainly is that last change that caused the problem. So we'll roll that back and rerun the tests. Well, it was that, so let's go forward in little steps instead. What did we do? Well, we said we'll have an in-memory items in here. And then we deleted the clear DB. But there's a fixture in it in here that's required to actually save the items. I bet that's our problem. So if we were to take that out, and we can also do that bit and run. Yes, that was our issue. And I think now we can do an apply in here. Just say init once we've created the fixture. So now we should be able to get rid of this. Let's check. And we're good. And now we can commit that as revert delete items tests use in memory items. Now we've undone some of the damage caused by our yak shaving. Let's just remind us what this in transaction is doing. What we did previously was in items load, we made that a context receiver function taking two contexts. One is this IO, that's just a marker interface to say that IO will be happening, it's not a pure calculation. And the other is this TX, which is a transaction context, which is there to remind us that we should have started a transaction in order to run this. And we have this in transaction, which starts the transaction for us. So that's why in stock here, this items in transaction is a block that has the context available for items load. And the implementation of in transaction in DB items starts the Duke transaction. Now what we could do instead is to have stock not start the transaction, but require that load and update stock list is called in a transaction. So if it doesn't do it itself, that would go away, and that would go away. And now the compiler says, well, you can't call that because you don't have a context receiver. But we can fix that by saying that we need a context receiver here of some tx context. Now over in the left-hand pane, you can see that's broken the compile. And that's because price stock list loader takes a function that knows how to load, but we're passing it a function that knows how to load that requires a tx context. Now we can fix that by saying this needs tx context and passing that requirement to the load on our price stock list loader. So this will require tx context in order to pass it to our loading function. In other words, because stock now doesn't start a transaction, we need to prove that we have a transaction when we call load in our price stock list loader. Now the compiler doesn't work properly, which is why we need this magic here. But this loading now requires two context receivers, so we've got to call magic twice. That's a bit of a shame, and it's especially a bit of a shame that it still doesn't work because we have to tell it explicitly the type that the magic is going to convert to. And note now that IntelliJ thinks they're not required, but if you take them out, it breaks. Now that's bound to have broken some compilation stuff, so let's build. And the first issue we find is that load stock list now can't call load because it doesn't have the transaction context receiver. We know how to fix that though, because we've got some items here and we can just put that in there. Note that the call to load and update stock list, this one here, is still compiling even though we added transaction context here, because we are already running this in this transaction block. But now we're not calling a nested items in transaction, which was the point. This load and update stock list and this save will now be both in the same transaction. Let's try building again. And now perhaps unsurprisingly, we have some places in test that now need a context receiver. Let's have a look at this one. This is the price stock list loader tests, which are calling the price stock list loader, which now requires a transaction context called load. What's the type of the transaction context here? Let's have a look. We don't actually have an items implementation, we just have the stock values and a lambda to fulfill this loading. So I think in here we could get away with saying, using no transaction, call loader load. Oh, and that's not using, but with. Any other errors? Oh, that one's the same, as is that one. So let's take this, select them all, and do the same thing, which is with no tx as the context receiver, call the loader to load. Try build that. And now in stock test we have the same issue because stock load and update stock list now requires a transaction context. In this case we have in-memory items, so I think we should be able to say, if these are all the same, they pretty much are, that expression, find them all, and then say items in transaction to provide the context. And now I think each one of these will say put arguments on separate lines, but that only works for the first one, so we can go and say there, and there, and there. Any more? I don't think so. Does that build? It does. Does it pass the tests? Well, it does. Good. And now if we return to our app, you can see that we now have two top-level functions, load stock list and delete items with IDs, that call various functions, this price loader load, this load and update stock list, and this item save, all of which require a transaction, and the context receivers have sort of guided that refactor, expressing in the type system something that would otherwise be sort of implicit knowledge, something that just happened at runtime. So I quite like that. It isn't perfect, in particular if we try and create an operation that calls load stock list and delete items with ID, then we're still going to end up with two in transactions. Ideally, we'd still like items in new or existing transaction. I have a cunning plan of how to achieve that, But Alison, the owner of Gilded Rose, is standing behind us tapping her feet because we've told her that we've almost finished delete items. So let's get on with that and finesse this other problem later. So we can commit this as move to a single top level transaction. Good. Before we go on, I will say I'm a little concerned that this TX context and this TX context need not actually be the same thing at the moment. I think in principle it would be possible to invoke load and update stock list with a database items, but with a no transaction context. If we were ever mixing types of items in our production code, I think I might be a bit worried about that. But as we're only using them in tests, I think I'm going to let it ride, maybe address it when we've made a bit more progress. So are we ready to ship this to production? Well, there's just one nagging doubt in my mind, and that's what happens in the error cases for delete items with IDs. What should we do if this set of IDs is empty, or if it contains items that aren't in our stock list? Now, the empty case can happen if we click the delete button without having selected any items. So if we do that, we get nothing back. That's what we'd expect. That's pretty harmless, but maybe we should write a test for it. Here's our existing delete items tests. We have two of them. One is just calling the app, and the other is going through our routes and actually doing a post and seeing that we get the redirect. It feels a little bit icky to be testing at these two levels in the same test, but again, I'm going to let that wash over me and just duplicate this test, and we'll call this delete no items. So if we were to delete items with an empty set, then what will we expect? Well, I think when we load, we'd want to get the same stock list as we started with. What's that up here? That's this. We don't have a stock list without prices. Maybe the fixture will tell us. Oh yes, there you are. Look, we have a stock list. So we can go back here and say we expect that to be our fixture.stock list. Oh, wrong place though. Copy that, undo. And that's the one we want in here. Run the tests. And we have a failure. Let's have a look. And delete no items has a full stock list, but the last modified is changed. Back to app. And here we can see that we unconditionally saved the revised stock list. And that will have the timestamp of the delete items with ID, not the timestamp of the original stock list. I'm not sure that's desperately wrong, but we could do better. So let's take this thing as a variable, which is new items. And now we can say if new items is not equal to stock list items, that's when we want to save. And I think we might inline that. And run the tests. Better. Now what about the case where the item ID says an ID that isn't in our stock list? That might come about if somebody had this page displayed for a long time and then went to delete aged debris, but somebody had already deleted it with another browser or in another tab. Is that a problem? Well, I don't think it is. These sort of things are really quite context specific. But if we interpret delete items to mean I don't want that item to be there anymore, well, by the time we finished it won't be. So I think the item not being there is also benign. We'll write a test to show we're okay with it. Just before we do, we can say delete no items doesn't save stock list, and then duplicate this, delete non-existent item doesn't save stock list. So in here we can say set of how to get item IDs, or we don't want to use existing ones, so we can say ID, giving it no such. That returns null, but we can double bang it in our tests. I think that's safe. And run. And I think we're good. Let's commit that as don't save stock list when items hasn't changed on deletion. And it's worth noting that we've only tested the common path via HTTP because you know that routes through this method here, which is now well tested. So let's commit that. And now in order to actually see that feature in production, all we need to do is make the feature flag default to true. So if we find our features, then we could set this to true. Now if we run the production main, and look on port 80, we see our delete. Quick sanity test against our test database. We'll get rid of the inscrutable quantum device, delete, and there it is gone, and there is our analytics event to show that it happened. So now we can prove that we've been busy by committing that. Deploy delete item to production. And once I push that and CI has built it, then we're done. Well then, everything seems to be working. Alison's happy. Now that it's deployed, we can remove the feature flag. So first, let's just find out where it's being used. We can find usages of that. Now we select it, and helpfully a data flow from here to see what actually depends on that flag. And the answer is in render. Here we are. So is deleting enabled in our stock list view model? Well, we now don't need that, so we can take it out. And we don't need it there. Now we don't need features in our render, but I'm going to leave it in, safe in the knowledge that we're about to start work on adding items, and we'll want to feature flag that as well. I can, however, say, let's suppress unused parameter for that for now. Run all our tests. And now we have a failure, and it's that list stock with deleting enabled doesn't have the UI. That's because our handlebars template has these ifs to hide the UI, so we can take that out of there, and there, and there, and there, and there, and there. Any more? No. Run. And now this time, it's our list stock without deleting enabled that's failed, and that's because we're showing the user interface no matter what. So if we go to the test, then I think we should be able to delete the list stock with rendering enabled altogether. Try running. Almost there. We should be able to prove that. And run again. And now if we look at the commit, now our user interface for production now has the form and the checkboxes in it. That's good, but we're not quite done because we need to go back to features. Now we can take this out altogether. If we do, the compiler complains that a data class has to have at least one item. So I think the easiest thing to do is to say val dummy, which is a Boolean, build. And now here are the places in our tests where we no longer need the flag. 1, 2. Our test main is now the same as main. And I think we may be done. Commit that. Just check those as I'm getting tired. We have removed is deleting enabled and replaced it with a dummy. Our list stock tests now have the deletion in them. Stock list rendering doesn't need the features. Stock list rendering tests doesn't need is deleting enabled. And so we've removed the test and the approved file. The view model doesn't need to check. And our test main can't use the flag. So this is remove now unused is deleting enable feature flag. One issue which we can check, and that remains unfixable, I think. Well, Alison, the owner, is pleased, although she points out that we haven't actually completed this story because it says add and remove items from the stock list. I think we'll split this story so that we can say we've finished remove items and just need to do the work on add, and that sounds like a good place to start the next episode. Before we wrap up here, I think it's worth just reviewing what went well and what didn't today. Because we've been making such small commits, removing the debug code by reverting its commit was quite easy. And then we've got an unexpected failure trying to revert the changes to the test by hand. It was quite easy to roll back to the last known good and then step forward more carefully. That found the problem quite quickly. The refactor from creating a transaction to requiring a transaction as a context receiver went well, I thought. And that's because we were using context in a way that was expressing in the type system something that would otherwise have been implicit. Reviewing potential error cases before publishing worked out well for us. We found a couple of places where we would have been saving the stock list even though it hadn't changed. And the tests are a very good way of finding and documenting that sort of subtle behavior. And then finally we deployed by changing the default on our feature flag, but leaving the flag in there, so that if we did have any issues with the feature, we could turn it off again quickly. In this case, that would have taken a redeploy, but in high traffic production systems, we'll often read the values of those flags from the environment, so they can be changed on the fly. And then finally, when we were happy that the feature is working and that we won't need to roll it back, we can remove the feature flag and any code that depends on it so that our system is as simple as it can be at the moment. Well, I hope you enjoyed this video. If you have, then please like it so that other people will find it, and consider buying the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.